Hi everyone, so today we're going to go ahead and evaluate trig functions of any angle. So in this lesson, as well as future lessons, you're going to actually be using the Pythagorean theorem, so we want to just review on what that means. Now A and B are your legs and C is your hypotenuse. So remember that your hypotenuse is always the longest sides. And we also have Pythagorean triples. Now these are just numbers that will make right triangles. Now this would be good for you to sort of memorize the more common ones so that way you don't have to do the Pythagorean theorem every time. But of course, if you forget and you're not sure, that would be fine too. So some more common ones are the 3, 4, 5 triangle. You have the 5, 12, and 13 triangle. You have the 7, 24, 25 triangle, 8, 15, 17, and 9, 40, 41. So just remember this is the leg, and then the last number is your hypotenuse. So now we're going to go ahead and look at the steps to evaluate trig functions of any angle. So here you have your steps right at the top there. So we're going to go ahead and figure out where our angle needs to be. So the first thing you want to do is make sure you draw and label the triangle in the correct quadrant. So if I look at my point, I have x and y. So if I have 12 and negative 5, that is actually going to be in quadrant number 4 because my x is positive, my y's are negative. Now if I draw my right triangle, what you're going to notice is that your x distance is going to be the 12, and then the y distance is going to be negative 5. And that makes sense because negative 5, the y values are negative in quadrant 4. Now, what you're going to have to do is taking this point as 12, negative 5, you're going to go ahead and find the missing side, which in this case is going to be your hypotenuse. Now, again, you can do the Pythagorean theorem, but you might notice that you have a 5 and a 12, so this is actually a triple. It's the 5, 12, 13 triple, so my hypotenuse is going to be 13. Please make sure that you always remember that your hypotenuse is going to be positive. So now we're going to go ahead and evaluate the 6 trig functions using the sides that we have. Our angle is, of course, always sort of based around that origin, no matter where the triangle is. So I have from there, I have my opposite side over here, I have the adjacent side, and I have the hypotenuse. So when I evaluate this here, my sine is opposite over hypotenuse, which is negative 5 over 13. My cosine is adjacent over hypotenuse, which is 12 over 13. And my tangent is opposite over adjacent, which is negative 5 over 12. Now here's the thing to remember is that these are all your reciprocal functions. So I just take all of my sine, cosine, and tangents, and I'm just going to flip the fraction. Thus this becomes negative 13 over 5, 13 over 12, and negative 12 over 5. All right, let's go ahead and look at another angle. So the first thing we want to do is want to determine, okay, well, where will my angle be? So my angle is going to be in quadrant number 3. So I'm going to draw my triangle. My theta is going to be here. And our angle is going to be such that secant is going to be a negative 7 over 5. Now remember that secant is the reciprocal of cosine, and it's going to be h over a. That means my hypotenuse is going to be 7, and my adjacent is going to be 5. Now again, if you're not sure where that negative goes, you must remember that the hypotenuse is always going to be positive, so the negative is going to go with the adjacent, which makes sense. That's an x distance that is negative. Now what we're going to have to do is we're going to go ahead and see that we need to find our missing side. So again, we don't have a Pythagorean triple, so we're going to have to do Pythagorean theorem. So we have 5 squared plus x squared and 7 squared. So negative 5 squared is 25. And then we get 49. We get 49 minus 25. We will take the square root of that. x is going to be the square root of 24. Again, you can simplify that. If you would like, you have 2 square roots of 6, or you can leave it at just the square root of 24. We do need to find the cotangent, which is the reciprocal of tangent, so that's a over o. So my cotangent of my theta, my angle, is going to be negative 5 over, we're going to have 2 root 6. Now here with our 2 root 6, you're going to have to remember that this distance is actually negative. So we're going to put that in our ratio. When we simplify that, my negatives cancel, so you can leave your answer as so. If you rationalize, again, you're going to go ahead and you're going to make sure that you multiply both the numerator and the denominator by the square root of 6. Just going to get you 5 root 6 over, this becomes 6 times 2, which is 12. All right, so another angle for us here today. We're going to have negative 2, negative 9. So negative and negative, that's in quadrant 3, my angle. Negative 2, negative 9. My theta is going to be right around that origin. So x distance is negative 2. Y distance is a negative 9. We're going to go ahead and find our hypotenuse. So we're going to have to use the Pythagorean theorem in this question again. And that equals my c squared. So you get 4 plus 81, and then you have 85. So c equals the square root of 85. Now what we're going to go ahead and think about is you want to find secant. So the secant of theta, secant is the reciprocal of cosine. So that is going to be h over a. And we have square root of 85, or my adjacent side, which is negative 2. All right, now we're going to go ahead and we're just going to practice being able to identify in which quadrants our terminal side's going to land. This is going to, again, help you in future lessons throughout this semester. The one thing that we want to have you make sure that you understand is our little mnemonic device, which is, again, going to tell you which trig functions are going to be positive. So you have all of them positive in quadrant 1, sine and its reciprocal, positive in quadrant 2, tangent and cotangent in quadrant 3, cosine and secant in quadrant 4. So again, let's just go ahead and practice. Our sine is going to be greater than 0, so positive in quadrants 1 and 2. And cosine is going to be negative in quadrants 2 and quadrants 3. So we sort of find that overlap is going to help us to figure out where that angle is going to be, that terminal side. And we would be landing in quadrant number 2. Here our sine is going to be less than 0, so it's going to be negative. That's in quadrant 3 as well as in quadrant 4. Our cosine is also going to be negative. That's quadrant 2 and quadrant 3. So that overlap's going to be in quadrant 3. All right, our cosine is going to be negative in quadrant 2 and quadrant 3. And our cotangent, so that's the reciprocal of tangent, that's going to be positive in quadrants 1 and quadrant 3. So that overlap is, again, quadrant number 3. And our tangent's going to be positive in 1 and 3. And our cosecant, which is the reciprocal of sine, sine's going to be positive in 1 and 2. That overlap, terminal side, is going to be in quadrant number 1. Now let's take this when we answer our next question. All right, so now we're going to go ahead and see where we are going to have this angle. Cosecant is the reciprocal of sine, and sine is going to be negative here in either quadrant number 3 or quadrant number 4. And then our tangent is going to be negative in quadrants 2 or in quadrant 4. So I know that my angle is going to have its terminal side in quadrant number 4. So there's my theta. And I know that cosecant is going to be negative 6 over 5. So cosecant, again, reciprocal of sine. So that's going to be h over o. So I have 6, and then I have negative 5. Again, remember, hypotenuse can only be a positive number. Now what I want to do is I want to find cosine. Now cosine is a over h. So I'm missing the adjacent. So I got to find the adjacent. Again, Pythagorean theorem. So negative 5 squared plus x squared equals 6 squared. And I get 25 and 36. X squared is going to equal 11. So I have the square root of 11 as my adjacent side. So again, the cosine of my angle theta is going to be the square root of 11 over 6. All right, so let's find out where this angle is going to be. We have our sine is going to be a negative. So sine is only negative in quadrants 3 and in quadrants 4. And again, my cotangent, which is the reciprocal of tangent, tangent is going to be positive. Tangent is only positive in 1 and 3. So that overlap is going to be in quadrant number 3. So my terminal side is going to be in quadrant number 3 with my theta. Sine is O over H, so my opposite is negative 8 and 17. You do have a Pythagorean triple, so my side that is adjacent is going to be a negative 15 because it's along the negative x. Now we try to figure out what secant is. Secant is the reciprocal of cosine, so that is, again, h over a. So the secant of theta is going to be my hypotenuse, which is 17, over my adjacent, which is negative 15. Okay, I hope this video helped you to be able to evaluate trig functions of any angle. If you liked it, go ahead and subscribe so you get future notifications on other videos. Thanks for watching and have a great day.